We are going to start our first session, which is the inaugural session, and I welcome Sri S. Kumar sir for his inaugural talk. You all know that sir is the architect of Earth observation system, and whatever system available today on Earth or the planetary mission, sir, it is the brainchild of sir who has made his contribution in different phases of his career. It is our honor to have sir on this for giving talk on Indian space program. Now I invite sir to start his talk.
Okay, I'll just try the sharing. You see if it's okay.
Yes, sir.
Are you seeing the screen?
Not now, sir.
H. So what I'll do is I'll take you through the journey of Indian space program. Today, as you are all very familiar, space is the new frontier, or it's called as the fourth frontier after humanity has in a way conquered land, ocean, and airspace. So way back in 1957, when the two superpowers, Americans and Russians, were competing with each other to demonstrate who is mightier and who is stronger. They were developing these technologies. But at that time, as you are very familiar, 1957 was just 10 years into independence. India, after getting the freedom, after many hundreds of years of external subjugation, was struggling to provide food, shelter, and education to its citizens. At that time, Dr. Sarabhai had a great idea of making use of this disruptive technology of going beyond Earth, and how to make use of it for rapid development in the country. So what he did was he actually visualized that if we are able to put a satellite in a geostationary platform, then we can do communication, and also for various weather monitoring activities, it would be very important. So having visualized such a thing, so he made sure that India entered this arena of space technology. And his idea was we should be second to none in the application of these advanced technology to the real problems of man and society. And then he also said our national goals involve leapfrogging from a state of economic backwardness and social disabilities, attempting to achieve in a few decades a change which has historically taken centuries in other lands. This involves innovation at all levels. And this is how he was actually looking at how we could make things happen. So in a way, what he did was he convinced his friends across America, Russia, France, and Germany, and he showcased to them that in Tumba, we are very close to the geomagnetic equator and a magnetic equator. And if you conduct upper atmospheric research at this place, the entire scientific community will benefit. So what he did was he got sounding rockets in the form of kits. You can even see that a person carrying on the cycle a part of the rocket for assembling. But all this only shows that no matter what your resources are, how limited it may be, but if you can actually visualize and keep working towards the end goal, you can achieve what you want. So at that time, sounding rockets was brought in the form of kit. The church, what you see here, is the place where the first sounding rockets were assembled. And in fact, even for conducting these experiments in that beach, actually, Sarabhai had to convince the fishermen. I'll touch upon that little later. And one of the things that India did at that time was bringing information to the entire country. And for that, again, Sarabhai conceived of an experiment where he took the help of an American satellite, one of the most advanced technology satellite, which was being built. And in 1975, for 1 year, India conducted world's largest socio-technological experiment. You are all very familiar today that with a small set-top box and a quarter-meter antenna on our rooftop, we are able to get a direct-to-home television. So you can imagine in 1975, when even power was not available everywhere, the difficulty of bringing in broadcasting service. And at that time, the only 4 cities in India had the privilege of looking at these broadcasting services: Delhi, Calcutta, Madras, and Delhi, Calcutta, Madras, Bombay. And these 4 places only had the privilege of seeing the television channels. And what India did was in 2,400 remote villages, using this 10-foot diameter chicken mesh antenna and the black and white television sets of ECIL, this was demonstrated. And what the Prime Minister of India speaks in Delhi could be heard in these villages. So with this, the government also got convinced that the quickest way for India to reach out to all its citizens across the country is to make use of a satellite transmitting signal from a geostationary platform operating at a height of 36,000 kilometers. And from that, the entire country can be covered. At that time, if an alternate mechanism were to be used, you have seen every 1 kilometer, you have to set up a microwave tower. And India is 3.25 million square kilometers wide. And if you had to make use of that technology, not only it would have taken long time, but also huge resources, and it would have been impossible to reach out all the hilly and non-reachable areas in the country. So with this experiment, India started its INSAT program, and that's how it went ahead. Similarly, another very important thing was, you're all very familiar that super cyclones, when it occurs, we used to lose in the earlier decades lives of the coastal regions where the cyclone hits. Tens of thousands of people lose their lives because you do not know when the super cyclone hits the coastal region. But now with the satellite data being available, it's possible to predict days in advance when a cyclone is going to hit a particular location, and based on that the lives are being saved. And today the and along the coastline, India is able to tell well in advance when the cyclone comes, and disaster relief agencies are evacuating the people there and saving lives of people. And space-based disaster management support, which enables well in advance information being provided, has enabled India to take advantage of this space technology. Another very interesting thing that happened is Dr. Sarabhai had to convince the fishermen that the they should allow us to conduct the experiments of launching these sounding rockets there. And with that, he actually had to tell the fishermen, with the help of the priest of the church there, one Bernard Pereira, and using his services, fishermen were told, you vacate this place and allow us to conduct these experiments. One day in future, the country will benefit. So what was being done from 1999 is, by looking at the color of the ocean from the satellites orbiting Earth, you identify the chlorophyll, and through the chlorophyll, the food chain of the fish, you locate in the ocean where, if the fisherman goes, he can capture the fish. In fact, just this one activity alone saves to the country between 10 to 15,000 crores a year, because what happens is the amount of petrol and diesel the fisherman has to spend in reaching the prospective fishing zone is saved, and also he is there assured of his fish catch. Today, with our own navigation satellite, this activity is taken one level further, and a mobile in the hands of the fisherman tells him, with the signal received from the navigation satellite in a small battery operated gadget fitted in the boat of the fisherman, not only it locates itself, like in your mobile, you know your position, latitude and longitude is known to you. And similarly, our Navic satellite enables a small gadget to identify the latitude and longitude of the receiver. And this communicates with the mobile in the hands of the fisherman. And an app on the mobile points to the fisherman like a video compass where to go for fishing. And not only that, it alerts him of the weather vagaries that could occur in the coming days, either heavy rains or heavy winds or even cyclonic storms, sea state roughness being unbearable. All this information goes to him in his mother tongue. So you can see what is happening here. A person who does not know reading or writing is taking advantage of the most advanced technology of a rocket putting a satellite into orbit, and through the instruments on the satellite providing both communication and navigation information, the person who does not know reading or writing is able to carry on his livelihood. So this is the real advantage of the space technology, and that's how India is moving ahead with making use of these capabilities. Similarly, in the early days, you are very familiar. If you had to reach out to any of your friends or relatives, one had to go to a telegraph office to do a person-to-person call. And if you are lucky that day, your connection would have come through. But now, a small device in your hands, not only are you able to see what is happening across the globe, but also you are able to communicate with them. All this is going on. India started its own program in 1975 by borrowing a satellite from America, but subsequently we started building our own satellite INSAT series, and today we have a number of these satellites operating in different orbital locations to provide communication. Not and the kind of services that are being provided apart from broadcasting, it's also all the direct to home television services, then the ATM services of the banks or stock exchange activities, and a host of them providing connectivity to mobiles, etc. is all possible through this. And even connecting the remote gram panchayats for providing information to them about the various government programs are all happening through the satellite communication. And then in addition to that, India also started enabling remote classrooms using satellite data. And this started few decades back. And then with, of course, more and more terrestrial communication improving, things are changing rapidly. But then India is still running telemedicine network where the patients from remote places like Andaman, Nicobar, or even on some villages, etc., being connected to super specialty hospital. And much of this became very handy during the COVID times, what you have seen, and things are taking much bigger shape. And then apart from this, navigation. So communication is one where you are able to do broadcasting or connectivity. Navigation is basically locating yourself, and India started providing a capability of reaching this information to aircrafts, and by putting a specific gadget in the aircraft, it is possible to help the planning the routes of the aircraft and also enabling them to do precision landing. India came up with a 7-satellite constellation for doing this job, while other countries like America, Russia, and Europe and China make use of 24 to 32 satellite constellation. India came up with only a 7-satellite constellation for providing this service to India and beyond its boundary about 1,500 kilometers. And then today, these services are being used in extensive activities. And as India started increasing the number of airports and also more and more remote airports, using this GPS aided navigation system has become very handy. And all aircraft registered after 2019 January are mandated to carry these receiver systems. And India is extensively using these navigation systems. And then another advantage you get of going beyond Earth is you can start making observation of any portion of the globe. You can see that space has no boundaries. There are no national boundaries or no state boundaries. So India started making observation way back in 1979 with Bhaskara satellite, which provided an image of 340 by 340 kilometers with 1 kilometer resolution. Starting with that, progressively we built imaging capabilities, and today we have better than 30 centimeter resolution imaging, and we can cover any portion of India in very many different wavelengths. We have devised imaging system which have been specifically designed for providing information about crop yield assessment, crop forecasting, and also in terms of planning and even identifying where if you drill a bore well, you can succeed in getting sufficient amount of water in those places. So for this, a continuous technology development was happening. And today we have built a series of remote sensing satellites which are providing higher resolution imaging data. Similarly, in terms of weather monitoring, you can see from geostationary platform, the by looking at India and its surroundings, and by looking at the cloud and its motion, you can determine the cloud motion vector, and you can also determine the temperature and humidity profile. And using all such data, you can fit it into models, weather monitoring systems, and then generate information for the India Meteorological Department to improve their forecasting ability of identifying when not only cyclones, but also even rain rate prediction, heavy rain occurrences, and heat wave information, all this. You will also be wondering many times, between June and September, India is actually cloud cover because of the monsoon. There is so much of cloud cover. So what can we really see from space when you look at that? So like glass is transparent to us for our vision, microwave sensors can penetrate through the clouds by building instruments which operate in very different wavelengths. You can make observation even through the clouds, and we have built a large number of satellites for providing information progressively, and with that we are able to provide a host of information. And we have been building various kinds of instruments for that. As you can see, telescopes of larger and larger size, and then with different resolutions and with different times of revisit. See, if you want to find out what is happening in a given region, what is important to you is how frequently can you make your observation, and with what resolution you can make, and in how many different wavelengths you can make. Obviously, you know that if you want to get to know more and more details of an object, more and more parameters you identify for characterizing it, it helps. So India has been building many different kinds of sensors. So while I can see only between 400 to 700 nanometers, you know that electromagnetic radiation occupies a very large wavelength region, and humanity is able to see today infrared, gamma rays, and even X-rays. So similarly, in microwave wavelength, if you build instruments, they can penetrate through the cloud and they can give you a host of information. There are also what are called active sensors. Like in a mobile or in a camera, if you do not have a flash, you have to make sure that you have sunlight available or an alternate source of light is available. But if you have a flash in your camera, then the camera itself becomes an active sensor, because you can flash light, and then based on the reflection from that light, you can take pictures. So similarly, in the microwave sensor, you can get data in various wavelengths. What is not visible to our eyes can be picked up from this. And using such sensors, today we have a large number of information being generated. One of the key things in any development for planning or even construction is to know about digital elevation model. So you are very familiar in geographic areas when somebody wants to construct a dam or even a building on a site, it is important to know what is the elevation differences, etc. So India has built satellites which can provide information about the height above ground surface, and using such instruments, we have covered not only Indian subcontinent, but also many of the neighboring regions, and also global data sets providing the stereo information. So today what we have done is using optical, microwave, multispectral, and also multispatial and multitemporal. That means if you want to know how changes are taking place, if you make observation of a given region day after day, you can see what changes are taking place. So for doing such things, using satellite data over last 3 to 4 decades, a large amount of information has been collected. And using our navigation satellite, today you can also do what is called as position dependent data collection. So in fact, this is one of the key capabilities which helps in lot of planning and monitoring activities. And with all such data collected and digital elevation data also being available, and using computers for running models, what India has done is it is using it for socio-economic security, then for sustainable development, for disaster risk reduction, and for governance. In all these areas, India is using these data sets. In fact, what has also been done is it is one thing to generate new information set, but another thing to make an effective use of it. So while India started its space program in the 70s and 80s, you can imagine that at that time, a lot of government departments which were doing their work by using alternate methods of data collection, they had to be convinced that the data collected from space can be used by them for making rapid planning and then monitoring of what is happening. So it was also necessary to go to these departments, talk to them, and convince them. And it is here that you see the human nature that comes into picture. So normally what happens is when you go to somebody and tell them that what they are doing can be done in a very different way, first reaction would be, I know my job better. Who are you to tell me? But then with persistence, you can make your point clear. And this is how you can see those space technology became available. Then adaptation of that and effective use of that took a lot of time and effort. Forest Survey of India started using this data way back in 87 to generate biennial maps of the forest cover of India. Similarly, Ministry of Earth Sciences using it for potential fishing zone and then also for crop planning. Then Ministry of Agriculture now uses it for various crop assessment and then telling before the harvesting what is the yield this year, what is the likely yield of wheat, rice, sugarcane, groundnut, cotton, like that host of them. Similarly, coastal zone coverage and then civil aviation. In all this, with this consistent effort, India was able to make more and more effective use of space technology. And here again, you can appreciate that when the people at the top realize that the data and the system can be used effectively, the penetration of technology happens much faster. In fact, in 2015, India ISRO conducted, along with the government of India, a program where all the secretaries of state and central government were brought together, and the whole gamut of what technology information is available, how the various departments can use it for their application was showcased. And on this day, actually, Honorable Prime Minister himself spoke extempore for 45 minutes, telling the secretaries how the space technology can be used in governance. In fact, Honorable Prime Minister, when he was Chief Minister of Gujarat, had used this information to identify where a new school should be set up by looking at, if you set up a school, how the walking distance from the villages to that school becomes reduced, and those places where earlier the distance was longer were chosen not on the basis of recommendation of any politician. Similarly, hospitals and a host of activities were being done for communication, connecting to the remote places, doing online activities, and then monitoring. In all this, the use of space technology became very essential. And today you're also very familiar, use of solar energy for solar power generation is a very important aspect. And what has been done is by collecting data from satellites of what is the solar insolation and what percentage of sunlight will be available in a given location. And not only that, you can identify the waves, the wind vector, and all this information used for power generation. Such data is collected using the satellites. And then non-conventional energy, wind energy, wave energy, solar calculators are available. Today, a huge number of solar panels are established across the country for making power generation. Another very important aspect is you can collect data of even non-reachable regions. And in fact, how the entire climate change studies have a set of parameters which can be monitored using satellite data over terrestrial regions, oceanic regions, atmosphere, cryosphere. And for all this, satellite data is actually generated, and there is a system called National Information System for Climate and Environment Studies. It provides such data through the website. And then enabling, I've already touched upon telemedicine and teleeducation network. And as you can see, space technology is a capability where instead of working in isolation, you can also work with other countries and then pool your resources and improve on the both information collection and its usage. India worked with France and Europe, Americans and Russians, etc., for providing a large number of data for various applications. And then, true to our national heritage of sharing the capability what we have, what India also did was it built a satellite called South Asia Satellite, and using this transponders which enable both broadcasting and communication activity to be provided. We actually share this transponders are made available to our neighboring countries. And in fact, one of the key things that happened when this launch took place was all the heads of the states of these countries were there on a common video program. And what the Afghan president said at that time was very interesting. He said, this is the first time we are seeing a promise made by a country being fulfilled in real quick time. So India, true to its heritage, is not only building a capability, but also sharing the technological capability with its neighbors. While all these activities of Earth observation, communication, navigation, broadcasting, etc. happens, India also all the time made use of its ability to go to space by looking at space science. As you can see, one of the key things that can happen is you can make use of observation of space from Earth also, but then atmosphere is in between you and the space. And if you can take out the atmosphere, your observation capabilities can become much better. So starting from sounding rockets in the 1960s, where upper atmospheric research was being done using this data, Aryabhatta, when it was launched in 1975, carried some scientific instruments which looked at some X-ray sources and gamma ray burst. And then with every opportunity, instruments were designed in that. And then 2008 onwards, we started building very specific scientific missions themselves. So I'll see some of the details in a subsequent slides. So one of the things that India did was initially it built its satellite and started going from low Earth orbiting. That means you put satellites going around Earth in 500 to 1,000-kilometer range, and these are low Earth orbiting satellites. And if you can put a satellite at 36,000 kilometers, the period of that satellite is exactly 24 hours, which is the same as time Earth takes to rotate about its own axis. So because of this, the relative velocity of the object with respect to a point on Earth becomes zero. And as a result of that, the satellite appears like a tower at that height. So you can do line of sight communication using that satellite. And Moon is at 385,000 kilometers. And then Mars, when it is closest, is around 225 million kilometers. So we have been building satellites and sending them to these different distances. And Mars itself, if you look at how we reached that, leaving the Earth's orbit, get into the sun's orbit, and then move on to reach Mars and then move around the Mars. In fact, just if you have to appreciate the technological complexity of this mission, on the 5th of November 2013, when this satellite was launched from Sriharikota, the task for the satellite was it should travel a distance of about 600 million kilometers over a period of 10 months. And at the end of that period, it should be at a specific location. You imagine in space a cube of 50 kilometers. After traveling 600 million kilometers over 10 months, the satellite had to be inside that cube on a specific day and time. That is on 2014, September 24, morning 7:30 a.m. At that second, if the satellite was not inside that cube, it would not have been possible for us to put the satellite into just that Mars's orbit. And what all could have deviated the satellite from its trajectories, even the sunlight falling on the satellite can deviate the trajectory of the satellite. So that was the complexity, but then all that could be achieved because of persistent efforts and then teamwork of the ISRO scientists and technology engineers and technicians. So 2008, when India did its lunar program, you are very familiar, man had already landed on moon, a large number of probes had touched the surface, but still Chandrayaan-1 gets the credit for discovering the presence of water molecules on moon, and then the process of water molecule formation was discovered by Chandrayaan-1. What it only shows is no matter when you start in the area of science and technology, there is so much more to learn and discover that it is never too late, and you can actually make a huge difference to the way the world comprehends this. And similarly, the Mars mission itself actually made the entire world look at the country, because India became the first country in the world to make in its maiden attempt a successful insertion of a satellite into the Mars orbit. Similarly, if you look at our astronomy satellite, space astronomy, what is actually this carries, you will be very happy to know that an indigenously developed telescope on this, even today, has the highest angular resolution and sensitivity in a particular wavelength region of far ultraviolet region, and it has the best telescope in operation. And then based on this, a large amount of our scientists are able to get a huge amount of data, and then they're discovering many new things on that. Similarly, Mars orbiter, while originally its mission was for only 6 months, but then it has survived for more than 8 years and completed its operation last year. And then AstroSat mission, it has the highest angular resolution even in comparison with James Webb Telescope. And then this is providing a huge amount of data to our scientists and researchers. And then Chandrayaan-1, like I told, it was a very unique experiment which we carried not only our instruments, but also it was an example of international cooperation, carrying many instruments of other nations. And then what it did was it changed the perception about the moon. In fact, in many ways, though man had landed on the moon, actually the interest on moon had waned. And then after Chandrayaan-1 demonstrated that there is possibility of water on moon, the interest again revived. And today you are seeing a large number of probes being going to moon, and then man mission to moon is also becoming more and more interesting for everybody. And America is planning its Artemis, and just a couple of days back, Chinese also have landed again on the other side of the far side of the moon. And all this in a way got revived because the Chandrayaan-1 demonstrated that moon is not bone dry, but there is water present in that. And it was considered geologically dead billions of years back, but then data from Chandrayaan-1 showed that it is dynamic and volcanically active in comparison to the scales of billions of years to millions of years. So we have a large number of data collected from Chandrayaan-1. You are able to see, in fact, you can see in this, there is a place where a safe environment, which could be a possible potential for future human habitat. So it is almost like a tunnel, a long tunnel with which inside protects against the radiation coming from space. And then such information has been collected using Chandrayaan-1 mission. And then while Chandrayaan-1 carried a moon impact probe, Chandrayaan-2, the objective was to land on the surface of moon in a controlled manner. But however, because of certain shortcomings in Chandrayaan-2, we were not able to land the Vikram lander and Pragyan rover. We came very close to doing it, but in the last minute, certain hitches prevented it from happening. But then we were able to get the data from Chandrayaan-2's orbiter, and this orbiter actually provided highest resolution imaging data of moon. And using this, we were able to actually not only identify a safe location to land, but in Chandrayaan-3, you saw last August, we are able to successfully land on the moon surface. In fact, it is data like this where you can clearly see even small boulders present on the surface can be picked up. It is our ability to collect data of this type using Chandrayaan-2 that helped us in planning Chandrayaan-3 activities and successfully land on Chandrayaan, that lunar surface close to the South Pole, very effectively. And you can also see Sarabhai crater as seen by the imaging system in Chandrayaan-2. And these are, of course, some more results from Chandrayaan-2. And Chandrayaan also carries the microwave synthetic aperture radar. And using this, a large amount of data is being collected. And it also helps in unambiguous detection of moisture and water on the surface of the moon. Chandrayaan mission, I'm sure you have seen a large number of videos, etc. I'll not get too much into the details, just to, of course, tell that this was based on the learnings and the inadequacies in Chandrayaan-2. We were able to plan the whole activities in such a way that learning from the previous mistakes, you build your capability and then effectively land on the surface of moon, and then the rover moved around the moon surface. In fact, one of the key things you should be able to visualize is India actually made use of this capability of doing multiple elliptical orbits for going around, because what happens is the rockets we built did not have enough capacity to put the satellite directly into a lunar trajectory. So what was being done is satellite was put into an elliptical orbit closer to the Earth initially, and then by firing the satellite each time it comes close to perigee, the apogee, the farthest point, was being increased, and progressively going like that, you could build up the velocity of the satellite and then move to moon, and then you do exactly reverse there. And using this process of using incremental velocity addition to the satellite was in a way has been perfected by us. We have done more than 5 missions now, 3 Chandrayaan missions, Mars mission, and also Aditya mission using such capability. And even though your resources may be limited, your capability may be limited, you can do very many things, is what was shown by this process. And these are, of course, just some images from now. And similarly, Aditya L1 mission, if you look at, is again a very interesting thing. Between the sun and earth, there are few specific points which are called Lagrange points. And then any object, if you put close to those Lagrange points, by virtue of the two-body dynamics, amount of energy required for retaining the satellite or an object in that location becomes very small. And if you are able to put the object there, you can survive for long periods of time with less energy expenditure. So using such a thing, today we have a satellite which is doing observation of the sun so that you can see what is happening on the sun. Because you are all very familiar, Earth actually its life is sustained by the energy we receive from sun. Any variation that happens from sun and also the kind of coronal mass ejection that comes from there can all contribute to life on planet Earth. So more and more information you can get helps in being prepared for various activities. So while you built all these capabilities, while we started in 1957, 10 years after independence, today we are already seen that we have become the 5th largest economy, and very soon we will become the 3rd largest economy, and then aspiring to become, by the time we reach our 100 years of independence, come close to #1 position. And if that has to happen, you also need to be contemporary in the technological capabilities. Today, if you see in space, India has already shown that it has built its own launch vehicle capability and it can go to different planetary bodies. But then one of the capabilities that is required is putting man in space. And India decided that by the time the 75 years of independence happens, we want to put humans into orbit. But then because of COVID and other related issues, it got delayed. But then we have already progressed significantly. And within a matter of a couple of years, you will see Indians going around the planet Earth and then coming back safely. And for doing this, a large number of new technological capabilities have to be built. You have to understand how to keep humans intact when they are going to space, what kind of suits are required, and what kind of training is required, how to make sure that you are able to build all this. Not only that, even the launch vehicle you are using should be capable of carrying humans safely and bring them back. If that has to happen, human rating becomes important. So all these capabilities. So today ISRO is working on this, building a huge capability. And even before this activity is completed, India has already decided that you want our own space station by 2035 and landing on moon by 2040 are the targets set. So if these targets have to be met, huge amount of technological developments have to happen. And also India is today the being the fifth largest economy. If it has to increase its economic capability, space technology, which is considered to be $1 trillion economy, you need to have more and more Indians working on this system. So India is trying to make sure that the space technology activities are promoted. And you see the in space, and also ISRO itself is providing its facilities for various private entrepreneurs to do their activities. And then for doing all this, building launch vehicle, we have built 4 different versions of launch vehicles, and we have done more than 400 satellites of 34 other countries. And all these capabilities have been indigenously designed and developed. So if you look at all this, what is it that has been happening? Like I said, it was Sarabhai's vision that India should leapfrog into the future through the adoption of appropriate technologies. Today, you are all very familiar that disruptive technologies makes a huge difference to the way world makes use of things. Like I said, communication, way back in the 60s and 70s, it was only through telephone, terrestrial connectivity that one was able to do communication. But today, by virtue of space technology, you are able to do that. And for all this, what India did was made use of the technology that was accessible to it, conceived of solutions which are relevant for our country. In the 60s and 70s, the demand was how can we make the entire country linked through communication and broadcasting? And then how can we provide information for doing various planning activities, whether it is for weather monitoring, cyclone tracking and prediction, or drilling bore wells, or learning about agricultural yield estimation, etc. So highest resolution. In fact, you will be very happy to know between 95 and 99, India had the privilege of carrying highest resolution imaging systems in the civilian domain of the world. So as a result of that, we were also able to provide globally this data using 18 ground stations across the world. Then in Mars orbiter mission, India demonstrated that you can do, even though your resources are limited, you can do interplanetary missions using those resources. Again, AstroSat satellite again shows that we carry the world's highest angular resolution and very sensitive telescope in a specific wavelength, making observations of celestial objects. And 104 satellites, when it was launched, it was again a very interesting activity. Now, leapfrogging as a concept, if you look at what is the leapfrogging, leapfrogging is nothing but if you want to reach a particular height, if you do not have the space, here you are seeing a person building momentum by running a certain distance, gradually builds up momentum and then takes off so that he is able to reach a higher point. But what if even that much space is not there for you? That is where frog crouches, conserves all its energy from one point and reaches great heights. So what India did also was like this. Whatever limited access it had of technology, conceived of solutions which were very different from what others had thought, and then brought it into reality and enabled India to reach where it has reached today. And if tomorrow has to be different, it is only possible when you become aware of what is the technology that are going on and how with those technology which is accessible to you, with that accessible technology, you can build solutions to the problems you are facing. So here you can see what Dr. Sarabhai said. A positive approach out of our predicament lies in finding solution where the particular disadvantage of developing nations, which is that they have little to build on, is made an asset rather than a liability. That's how he conceived of borrowing satellite from America, demonstrating how communication can be done in the country, how broadcasting, etc. can all happen. And then by doing simple experiments to start with, and whatever is not available, build using your own resources and demonstrate that you can do things which others have not done. So it is necessary for them to develop competence in advanced technologies and to deploy them for the solutions of their own particular problems, not for prestige, but on sound technical and economic evaluation involving commitment of real resources. Similarly, he said, those who can apply their insight into the problems of the community and of the nation discover an exciting area of activity where effort is rewarding even while the results come slowly. In fact, many times when people ask, how is it that people at ISRO are able to achieve things, you can see there is a particular thought process here, which is in the backdrop of such activity. And another very important aspect, particularly valid in today's world, is it is good to recognize how to relate oneself to other specialities without growing through a sense of failure. This is an outlook difficult to attain, but is nevertheless essential before one can really reach one's goal. And another really interesting thing, which is much more important, is this. The important ingredient for satisfactorily meeting the challenge of the changing environment is not experience, but an ability to learn. Experience is less relevant than the knowledge and the ability to learn and innovate. Today, this is a problem people are facing across the globe, and more so teachers, because the task of teaching earlier, it could have been one way. The people who are actually doing the job of teaching are doing it from a level where they had both information and knowledge, which was very different from the one who is learning. But today, because of the easy access to information and the information explosion, and the student has access to a lot of information through internet, through YouTube, through videos, etc. But then information alone is not adequate, and making sense out of that information is what is important. So if we are able to tell the child how the experience is important and how knowing has to be translated into knowledge and action. In fact, for this, I can take a couple of examples. The other day, while having discussion with one of the programs, I came across Kamya, who was a 13-year-old girl at that point in time, had already climbed 5 of the 7 topmost points on Earth. And she had promised by the time she becomes 15, she will conquer Mount Everest also. In fact, just a few days back in the papers, you saw Kamya had climbed Mount Everest, though it went beyond 15 years, but she has achieved the Mount Everest climbing. Similarly, I saw a person who had actually cycled across 4,000 kilometers of America in a few weeks' time. And then similarly, a born blind person able to answer a 10 digit by 10 digit addition, subtraction, multiplication. You just ask him the question, he's answering. He said Shakuntala Devi was an inspiration for him. So what it all shows is each child has, and even you are familiar that there are people who can complete 100 meters in 9 few seconds. The potential is enormous, making them realize that they have the potential. If they put in focused, dedicated efforts, they can achieve success. And it is here that what is important is not so much the experience, but the ability to learn. And then this ability to learn becomes more and more valid, while it is said today process of learning is more important than the content of learning. So that's how things are moving. And Dr. Sarabhai, in more than one ways, has shown all that way back in the 60s itself. Another last point which he made, which I find it very interesting, is technology is not an objective to be aimed at, but a tool to be used for the benefit of the common man. If ISRO has shown something today, it is how the adoption of space technology can be used for the developing service of the country. Today, India moved from its early days of independence, where it had to struggle for its food, shelter. It has reached the 5th largest economy. It's among the leading countries which solved the problem of COVID and even digital stack, and it is moving ahead in all directions. So we are poised for a great leap. And if that has to happen, all of you teachers have a great role to play, because through your hands, the next generation continuously passes. And what you can provide to them and make them grasp in this period can make a huge difference to their own lifetime and their own life's experiences. So let me take this opportunity to wish each one of you a great success in your ability to grasp what is happening in the world, and through your own ways, make it known to the children you come across and make them better learners and make them experience things, and through experiential learning they learn ways of solving problems for the society. Here I'll stop, and if you have any specific questions, etc., I'll be more than happy to take it. Thank you very much for the patient hearing.
Thank you, sir, for giving the excellent talk and covering the wide spectrum of technology and its application, particularly the communication, the weather satellite, the navigation, Earth observation system development, space science activities, Chandrayaan, Mars, and AstroSat, and the challenges which we encountered during all those things, and the way forward, sir. Sir, I have found that from the chat this kind of things that it is highly appreciated by the participants, the school teachers, and they have conveyed their best wishes and thanks for for giving informative talk. So there are many questions on this line. I mean, it is flooded with so many questions and suggestions. But for sake of the limitations of time, I'll be taking a few questions. First questions that I will take like this is a question like, what is the role of satellites in weather forecasting? How ISRO collaborate with IMD?
Okay. See, you can see weather forecasting, why it became improved after the satellites became available is, before the space technology was there, the information that you collect could be collected over the surface, wherever you have set up some observation station, temperature monitoring, rain, etc. Lot and even wind speeds, lot of ocean. Earth is covered with a large amount of ocean. Once the satellites started becoming available, you could make observation over the ocean and determine various parameters and feed this data into the models. So any model requires information to be fed into that, and then at a given point of time, it takes all the current status of information, and the model predicts for tomorrow, day after tomorrow, or weeks later using the model. So while earlier models were built on limited data sets of data over only land, and that too limited depending on where the humans had set up observation station. But once the satellite started becoming available, it was possible to cover the entire globe. In the same way, India also, around the Indian subcontinent, we were able to provide very high frequency data. Today, for example, every 15 minutes, we can collect data over the Indian subcontinent, tell about humidity, temperature profile, and many parameters. In fact, there are also what are called sounding payloads, which cover at different heights of the atmospheric layer information. And all this information goes into the numerical weather forecasting model of IMD. And this data, there is a ground station and a facility set up at IMD Delhi, where the satellite data is received, converted into parameters which go into the model, and model does the forecasting. So whether it is cyclone or even heavy rain and then heat wave prediction, for all this, the satellite data collected by ISRO goes into these models. And this is in addition to all the other data they get from global network, and also their own automatic weather stations set up at various places, and then even weather radars which are established. Today, the effort in the country is increase the number of observation points, and then making sure with more and more input data going into the model, improve the efficiency of the model to give better forecasting.
Thank you, sir. There is similar question, and the question on similar time, the subject. In the question is, any website is there to see the weather patterns? And one question is whether a student can cooperate in weather info.
Yeah, see, this is where one of the things I was trying to mention was the following. See, today, for example, depending on wherever you are, near your place, there is a high resolution weather forecasting system from what is called as the SAC has a website where MOSDAC, which actually forecasts for next 72 hours the temperature, rain rate, etc. One of the things that can be done is you can set up some simple experiments in your school, and a system which monitors the minimum temperature and maximum temperature of the day, and using some simple gadgets collecting rainwater that is falling there. So identifying even rain rate, etc. Today, there are also small technology tools, a speaker being converted into a simple experiment. What is the rain rate? In fact, students can come up with their own methods of validating this. So you can collect on a daily basis what is the information there, what is the amount temperature, what is the sunlight, etc. And then compare it with the prediction. And over a month, you can do this experiment over many months. Over 6 months, you can do a comparison and tell how good or how bad was the prediction. It's only when validation happens that things improve. It is one thing to predict and tell what is happening. Another thing is to validate. In fact, what student groups can do is this kind of activity where they can actually look at what is the prediction that is there and do the exercise over a year and tell for the region where they made the comparison, how good was the validation. So similar experiments can be done for geospatial technology also. In fact, with respect to a well, what is the depth of the water level in that well? If you are able to do it 3 to 4 times in a season, then post-rain, post-monsoon weather level increased or not. There are some very simple methods which could be adopted. It could be as simple as something thread tied to a thread, insert it into the well, and when it touches, pull it back and then measure the length. So there are a host of things you can do. You can also take a laser light, flash it, pick up. In fact, today's students can devise such gadgets using their own experiment. In fact, if you are able to make use of it, you would really teach them how to collect data, how to validate it, how to fit that data into simple models.
Thank you, sir. There are some questions or in fact need that they want to have some more elaboration on satellite use for fishery application.
Yeah, that probably in the subsequent exercises where there is a specific talk dedicated for space application. I think it is Shantanu Bhatwadekar who is going to do that. He'll be
Yes.
there. But today, what I only wanted to bring to your notice is that even a person who does not know reading or writing, how he is getting the benefit of this technology. So the whole idea is to enthuse you into something. I'm sure if you search the website, you will be able to get a lot more information on this.
Sir, there is another question that how we are able to connect these satellites which are long distances from us.
Okay, basically the thing is simple. One is, light, electromagnetic radiation, for example. Signal travels from one location to another. See, earlier radios, if you are looking at, radio had a small antenna and it was receiving the signal from a transmitter which is kept at some particular location. So signal transmitted from the transmitter travels from one antenna to another antenna. So today, if you have a set-top box with a small antenna on rooftop, it receives the signal from the satellite. So you can do long distance communication using electromagnetic radiation, and that's by designing specific things with that radiation, what it's called a carrier, and on the carrier you can modulate the signal. I'm sure when you are listening to communication being told, you will be able to appreciate. On the carrier you modulate. Earlier, for example, you can see, suppose I simply switch on and switch off a torch sitting on a mountain top, you are at the other end. Then if I switch on, if I say I'm telling you something, if I keep it off, it is saying something. So I can devise a code. Within few seconds, if I turn on 5 times, it means this. If I turn on once, it means this. So that means a priori, you have coded the information. So at that time, you can receive the code. All that happens is very similar. This has been happening from ages. People have used on top of the fort, lighting a lamp for sending information. And then all this is, at that time, visible light was used. Today, we have built gadgets which can do in a much more accurate, much more faster, and much bigger information set can be done.
Thank you, sir. There are some curiosity related to education, like some questions are there, how the space education can be embedded in school education. And somebody asked, how can this concept be practically taught to students?
Yeah, I think this is one of the challenges. And of course, currently already capacity building program office is also working with NCERT and many others and try to bring in as part of the curriculum and as part of the text itself certain information so that certain minimum things that can be made aware of, children can be made aware of as they keep growing. And the efforts are on, more and more will be required. Each one of you who have an idea actually can pen your thoughts and then give it to capacity building program office so we can make use of it in getting it incorporated for future NCERT syllabus setting, etc.
So somebody is asking why we are not providing Navik on mobile as a indigenous navigation system, something
Yeah,
like that.
very good point, but it's already there. There are many mobiles which have enabled Navik, and Navik enabled service is already available, and all future mobiles, the government is also making it mandatory for future mobiles to be Navik enabled. So today also there are a large number of gadgets which make use of Navik for these activities.
Then one few last question let me ask, although there are many questions. Uh, is there any upcoming project on ISRO related to life on Mars or something of that nature?
Life on Mars, of course, is still our next Mars mission. Whatever is planned is still some distance away. What we can do currently is only through indirect evidence like methane observation. Of course, our attempt in Mars 1 we could not get very significant input. We have to build much more accurate and much more sensitive instruments for determining through remote sensing the ability to look at the occurrence of life sources on Mars. But at this point of time, we do not have any very concrete experiment that's planned.
Sir, one last question is INSAT series of satellite is still used for TV broadcasting in India?
Yes, INSAT 3 series is still used. INSAT 3 series is used for a large number of activities for connecting and also for not only broadcasting for Earth of the atmospheric modeling. It carries instruments which provide information every half an hour and as a constellation every 15 minutes. They are located at different longitudes. It also carries what is called data relay transponders, which picks up information from ground observation and provides to this. So it has got broadcasting, it has got DTH service also being provided through the private enterprises. So large number of broadcasting communication activities are happening through INSAT 3 series.
Thank you, sir. So I'm closing this question and sir, although there are many questions and people a lot of interest in such kind of activities. So it is a good sign that people are getting aware and they want to know more and more on that. But due to limitation of time, we'll be closing here. But and thanks, sir, again for giving such a informative talk to us and covering so much big canvas of knowledge of space technology, sir. Thank you very much.
Thank you. Wish you all the best for your course and wish all the teachers a great success in their ability to deal with children what they encounter. Wish you all the best.
Thank you, sir. Thank you.